My name is Josh Arnold. Today I'm going to be talking about our urban agroecology survey that we did over the past 2 years. I'm also going to be talking about an assessment tool a little bit. So it was really interesting to hear your talk right before this. Very lucky to have been partnered with Sarek Madsen and Miguel Altieri and Celine Palud on this, as well as Courtney Wilson. And we were sponsored by the Berkeley Food Institute Seed Grant. And I encourage you guys all to check out the Berkeley Food Institute. There's some really great work coming out of there. So the purpose of our research was to better understand the diversity of challenges faced by urban farms in the Bay Area. So we conducted a series of farm visits and farmer interviews over 2014 and 2015 growing seasons. The data was collected on 24 different farms and gardens, and I'll use the word farms quite frequently because I just refer to all of our gardens as farms. I see them as very small farms. And we looked at many different factors: agroecological practices, crop diversity, yield, access to equipment, many social and organizational factors. And we wanted to get a really holistic view of what was happening on these farms. So each of our farmers did a 27-question survey, and we continue to do this from season to season. So if we see any changes over time, we can capture that. And we also measured about 9 different factors on the farm. So we looked at the size of the farm, the size of the production space. We did diversity indexes on what kind of crops they were growing. We did 3 different kinds of yield analysis that I'll talk about shortly. We looked at non-crop habitat on the farm, so what specifically they had on the farm that was either set aside for non-crop usages. So we looked at pollinators or potential habitat for beneficial insects. Like I said, I'm going to have to remember some things without my presenter view. So we were really motivated to do this because of Nathan McClintock's work in 2009, the Cultivating the Commons, where they did a land inventory in Oakland, and they looked at public land that was open space. And Nathan came to the conclusion that there was about 1,200 acres in Oakland that they could be used for urban agriculture. And this begs a lot of questions about the benefits of using this land for urban agriculture. And one of the things that we were really interested in is how much food can be produced on those 1,200 acres. So Nathan's calculations were around 13% of the city's fruit and vegetable needs could be met by these 1,200 acres. And I'd like you to remember those numbers because we're going to come back to that when I talk about our yield analysis. So this is what we're going to talk about today. The aspects of the survey that I have time to talk about are yield and productivity, crop diversity, water and irrigation, pest, weeds, soil fertility and soil analysis, the disposition of the harvest, and the assessment tool. So we did a 3-part yield analysis, and I want to urge that we wanted to look at yield on these farms not only because we think it's something that's important. We know there's many other multifunctional uses for these urban farm spaces, but we do think it's an analog for best practices. So we think it's important to get an idea of what is happening on these farms as far as yield goes. What we did was we used data from John Jevons and a couple other sources to look at what specifically each plant produces over a season. And what we did is we went in and we took quadrat counts in the gardens and used that as our data. It was basic estimates for kind of medium scale agriculture, and certain crops were associated with a lot more productivity, and we had to kind of figure that out on our own and divide that by the life of the plant and the amount of seasons. This is one of our 6-meter quadrats that we have kind of roped off here, and we did, like I said, a 3-part analysis. Over here is our 6-meter quadrats, and what we did is we roped off these 6-meter square, and we provided a scale, and we provided a notebook, and we said, listen guys, anytime you harvest anything out of these plots, we need you to weigh it, we need you to record it. Can you do that? They said, yes, we can do that. And then we came back about 3 months later, and we said, all right, let's look at the notebooks. and there was nothing in them. so they said, maybe we didn't do as good as we thought we were going to do on that. And I said, yeah, you probably didn't. And that was definitely reflected in their numbers. So we see about between 1.3 and 2.4 kilograms per meter squared on those. So we took that methodology and threw it out. These folks are already working really hard. They already have full-time jobs and are doing other things. So maybe expecting them to weigh everything is maybe a little bit too much. But what we did do is, like I said, we took productivity quadrats. So we took 1 meter square quadrats out of our farms, depending on the size, and we counted everything in the farm. So everything in that quadrat. So the weeds, the crop plants. We looked at the practices that were being used. Was it a raised bed? Was it in the ground? Was it mulched? Was it on drip? Just anything that we can look at there. And what we did is we checked that against the productivity space of the farms. And we came up with about 7.71 kilograms per meter squared per meter squared, which is about 17 pounds. And this is about 30% better than what Nathan McClintock's numbers were. So we know, and that's after being adjusted for taking away about 40% of that for loss. So we know that urban farmers are producing an incredible amount of food. Which is really, really exciting. About 17 pounds per meter squared is really great. And the great thing is that we developed this methodology and we weren't really sure if it was going to reflect what was actually happening or not. But we did have several farms that do weigh everything that comes off the farm. And so we measured their productivity space and double checked, and we came pretty close to that number. This is just one season, just one short growing season. So obviously in the Bay Area, you could probably double this productivity numbers. The other thing we wanted to look at was crop diversity. So in 2014, we just looked at our 1 meter quadrats, and we wanted to look at what was the diversity, both genetic and crop diversity on the farms. And we came back about 3 different crops per meter squared. So that was great. We saw a lot of intercropping, and we saw a lot of mixed agriculture in the urban farms. We were really excited about that. And going back to what you said about lack of genetic diversity, we do see a lack of genetic diversity. So we see about 1.3 different varieties per meter squared. So not only did we count the crop types, but we also really tried to get in there and figure out the different cultivars that people were using. So we would really like to see some more genetic diversity in the farms. There's definitely a narrowing there. But what we thought was that in 2014, those numbers didn't really reflect what we were seeing, because what we see is this really diverse farming system. So we went back this year and we just took 8 meter transects and came back with about 9.5 species per transect. So I think that shows the genetic diversity, or the diversity that's happening on the farms, and still doesn't quite speak to the genetic diversity that we'd like to see more of. The other thing that we looked at was water and irrigation. This is something we're really concerned about in urban farms. We know the cost of water is expensive. We know it's been a drought, and who are going to be the first folks that people look to during a drought to say, we want you guys to reduce your water usage. And so urban farms are really concerned about how they're going to keep maintaining irrigation on a level that's going to maintain their crops. So we can see here that about 43% and 37% are from organizations and from donations, respectively. So the cost of that irrigation water is being absorbed by kind of umbrella organizations, or it's being donated by somebody. Only about 19% of our farms are actually paying for water. And we have about 1% that are on wells. So we do see what we interpret this as some water insecurity here, in the means that if the donation stops or the organization decides that they can't pay for irrigation any longer, then the farm can probably no longer operate. Many farmers indicated to us that they wouldn't be able to pay for their own water sources. One of the things we looked at was how much infrastructure there was for water harvesting, and there was only 3 farms that had water harvesting infrastructure. This is actually the 4th. This is the student organic farm at UC Berkeley. They just installed this water tank. But we looked at it's AB 1750. It's the Rainwater Recapture Act. It was passed in 2013, I believe. And one of the goals is to reduce pressure on metropolitan water systems by doing more water harvesting. And it exempts all water captured by rooftops for any kind of regulation. So urban farmers can actually now capture a lot of water off rooftops. And just for an example of how much you can capture, a 10 by 10 rooftop, say a garden shed in Oakland, with about 23 inches of average rain in Oakland is what it is, I believe, captures about 1,600 gallons of water a season, or annually. So it's a fair amount of water that could definitely probably take some of the pressure off. Later on, we would love to correlate or look at see if there's some relationships between soil quality and irrigation demands on these farms. Pests, this is all self-reported by the farmers, so we wanted to say, hey, you know, what are your main problems with pests that you are experiencing? You'll notice aphids, snails, slugs are the top three, and I'd like to draw your attention to the fourth one. Many folks noticed that there was this symbiotic relationship that was happening between the ants and the aphids, and when this was happening, that they were having a lot of problems with pest control. And so I think a lot of these numbers where people are self-reporting is when there's actually Argentine ants on the farm, and they're working with the aphids and protecting them from beneficial insects. So I think looking and addressing those issues is important for biological or conservation biological control on the farms. And this was the pest control methods that most folks turn to, mechanical or a homemade insecticide. And this is stuff like pyrethrum T. But most folks aren't using any kind of heavy insecticides. It's mostly all organic methods or IPM methods. Weeds was an interesting one. This is also all self-reported by the farmers, what their main weed problems are. Everybody indicated grasses were definitely an issue. But a lot of the other weeds that they reported, 8 of them in fact, are all edible. So this is something that we really wanted to get out to the farmers, that some of the stuff that they were used to, this is a difficult one. Oxalis is also difficult. Mallow a little less difficult. But stuff like dandelion and purslane are all fairly available, and we're actually even seeing dandelion and purslane showing up in farmers markets now, and people are paying good money for it. So this stuff that people were saying, this stuff's a real problem. We say, oh, it's edible, you can use that. So that was pretty interesting. Soil fertility management, we asked them, what are you guys doing to manage your soil? And most folks, about 60%, said obviously they're using compost and worms and worm castings, and fish emulsion were some of the other ones that were self-reported. I'd like to draw your attention to the compost and the fish meal emulsion, because we did see some interesting things when we did our soil analysis. So we worked with UCANR to do some soil sampling, and they measured heavy metals on 10 of our farms, and we measured fertility, nutrients on the soil. One of the things we saw was that there was no nutrient deficiencies at all, except for one farm that had a small copper deficiency. But we did see nutrient excesses, especially with phosphorus. So huge phosphorus excesses and a lot of organic matter. So all the times we've been telling people, you just got to add organic matter, they've been listening, and they've been adding organic matter. So this begs the question, can farmers actually use less compost and maybe possibly reduce some of their costs? That's a great question. So a lot of the beds that people are using, especially if it's a raised bed, is almost always just 100% municipal compost. And that works pretty good. So sometimes it can get a little weird, but it works really, really well. So when we did soil analysis test for heavy metals, we tested baseline soils. So we tried to get a baseline soil account, and then we did also test some of the beds. But for nutrients, we were only testing the beds. And only go down to that baseline soils. Only one of those popped as higher in lead. And this is obviously prevalent in urban gardens. It wasn't to levels that were too worrisome, which can be debatable when it comes to lead. But what we did is worked with that farmer to make sure they were using all the right practices to reduce risk. 50% of our respondents are composting on site. Almost all are adding compost, and 93% of them are cover cropping, and 66% are rotating, which was absolutely astounding. So definitely seeing some cool best practices in these farms. Where does the harvest go? This is something that we always get asked. And this is the aggregated data for both years for the harvest from all the farms that we measured. About 69% of that goes to community farmers. That got really weird, transferred over strange. So the people that are working on the farm or the immediate community is getting the food, which is probably contributing to food security. 10% goes to outside organizations like soup kitchens or shelters, and then about 21% is going to markets or CSAs for economic means. And actually, one of our farms has a really great model, Acton on Verba in West Oakland. They run a CSA where all the profits from the CSA go back to the kids that help on the farm and actually get put into college accounts for the kids. So there's a lot of really interesting models of how they're giving back the profits from the CSAs. Security of tenure is another factor that we wanted to look at. So we broke this up into three. Obviously, it's a little bit more complicated than this, but about 23% of our farmers had kind of long-term agreements with the property owner and were pretty secure where they were at. 33% had short-term agreements or short-term leases, usually year to year, or had a memorandum of understanding with the property owner. And about 42% fell in some place that was fairly insecure, which I would add wasn't stopping them from any kind of investment into the space. So, once again, the assessment tool. One of the things that was really important to us when we started this project was that we wanted to give something back to the community. And we had heard, from our farmers over and over again that, researchers come and they take measurements and they do things with us, but then they leave and we never see them again. So what are you guys going to do for us? And one of the things we did was provide soil tests, and that was a really helpful thing for those farmers. But first off, I told them I'm only in my second year of my PhD, so I'll be around for much longer. You're not getting rid of me. And then what we wanted to do was develop an assessment tool for them, something that was simple and easy to use that they could use to assess agroecological best practices on their farm. So we're on our second version of it, and this is much less elegant than John's version, but this is only the first page of it. This is version 2. Last year's version worked out pretty well, but once we reported back to the community, they had some adjustments that wanted to be made, so we worked with the community, and now on the final stages of version 2, we haven't attempted to put it online or anything yet, so I want to talk to you about that. Right now it's all just paper, and then we do generate some computerized reports for them, the prevalent amoeba or radar diagram. So we're looking at 13 different categories, and each one of these categories has a subset of different factors that gets measured. We're really invested in making sure all our measurements are easy for farmers to do in the field. So quick and easy infiltration test for soil, among other things. And the other thing that we're really interested in is resiliency of urban farms. And we want to be able to use this assessment tool to also assess resiliency. So obviously farms are at risk. We want to look at their climatic threat, which is mostly, obviously drought, among other things in California, possibly the spread of pests or more diseases, and use the assessment that we already have to measure vulnerability and reactive capacity. And then we can plot that on our risk triangle, and the axis are threat, response capacity, and vulnerability. And we can put that in there, and it will give them a fair idea of how their practices are transferring over to making that agroecosystem a resilient space. In closing, everybody that we worked with wanted more interaction with the research community. They specifically wanted to see more participatory research, and that's something we'll be working on in the future, is developing some participatory research projects with them. One of our farms insists that they were able to deal with symphylan infestations by heavy faba cover cropping. So if you know anybody that has symphylan infestations, we would love to talk to them and possibly do a participatory research project with them. they want more connection with current research pertaining to what's happening on their farm, especially best practices. These farmers are not stupid people. They know what's going on, they're managing their ecosystems, they're doing a really good job at it, and they want research. They want to see research about what's going on. And so that's been really entertaining, being able to start to bridge that gap. They want more farmer-to-farmer workshops, which is difficult. It takes a lot of logistics from the community and from researchers, if that's something you're willing to do, but it does have huge payoffs. And they need more support as far as policy and development goes, and there's a great need in the East Bay right now for all of these. And I'd just like to thank all of our 24 sites. I've loved working with the community and will continue to work with them, and all of our student researchers and everybody else. And we have a nice little website now that talks about our research. It's urban.agroeco.org if you guys want to check it out.